we're going to learn the topic kinematics. Okay, so kinematics is the study of motion of a body. So you have studied this probably on physics. Okay, I'm not very sure, but this is partly a physics subject. But we are going to focus more on the mathematics of kinematics. Okay, so in kinematics, there are four important things. Okay, as you can see on your screen right now. So the first one is displacement or the displacement function, and we use the letter S for displacement. Okay, this one. And then the next one is the velocity function, wherein we use the letter V for velocity. And then we have acceleration, which is letter A or the acceleration function. And then what's the fourth one? Okay, I said four important things. So the fourth one is this letter T here. Okay, so what is this letter T? T is obviously this is time. Okay, so that is the time. Okay, because time is only the constant thing among these three: the displacement, the velocity, the acceleration. Okay, so everything here is mostly measured uh, in time. Okay, and then what are these arrows here? Okay, so basically, class, kinematics in additional maths. Okay, is an application of differentiation and integration. For example, okay, if you're given the displacement function and you want to find for the velocity function, you just need to derive the displacement function. Okay, and then if you want to go to, if you want to find the acceleration function, given, let's say, the velocity function, you need to derive the velocity. Okay, so that means, let's say, if you're given the displacement function and then the question is about acceleration, that basically means that you need to derive the displacement function two times. Okay, so one time and then another one. Okay, so basically it goes in reverse. So if you're given the acceleration function and then the book or the question is asking for the velocity or the displacement, basically you need to integrate those functions. Okay, so this is very handy when we solve kinematics. Okay, all right. So uh, let's talk about the three important things. Okay, including time. Okay, so the first one is displacement. Okay, what's displacement? So displacement of a particle or an object is measured from its origin to where it is. Okay, for example, for example, you're driving in a car from point A to point B. Okay, now obviously in real life you won't drive straight like that, right? Okay, so basically you will drive like that. Okay, so this one, okay, this one, the line or the curves that I just made, that's your displacement. Okay, and then what's the difference between displacement and distance, right? You might be wondering. Okay, so distance is this one. Okay, without considering the curves or the turns. Okay, so the distance is just you know the measure from point A to point B without considering, let's say, the road that you went through. Okay, so that's the difference between displacement and distance. Okay, where is that? Okay, so let's have the two types of displacements. Okay, these are very important in this chapter. Okay, so the first one is turning or no turning. Sorry. Okay, so in no turning from, let's say, point A to point B, so you just straight away go right there. Okay, so if the function of S, T, is the displacement function describing the displacement of the particle from the origin, by the way, every displacement or kinematic question always starts with the origin. Okay, so at 0, 0. Okay, then, so the distance traveled is the function of uh, S of 2. So you just solve that one. Okay, and then the next one, letter B, is with turning. Okay, so with turning, okay, so let's say a particle starts from the origin, goes to, okay, after 2 seconds it's here, okay, and then after 2 seconds it went back, okay. Okay, so after 3 seconds, it's now here. So it's like, yeah, like that. So if it's like that, class, if the question has a turning question, okay, or the question involves the particle going back to the origin, because this is the origin, right? Okay. Uh, this is your, let's say, your formula, okay? So the distance traveled is s times 2, or sorry, s of 2 times 2, so twice of this, because you traveled from here to here, right? And when you go back, okay, so that's basically times 2, right? And then why do you have to subtract s of 3? Why do you need to subtract this? Okay, because this part, this is missing, right? So basically, this is the function of 3s, okay? So you need to subtract this. Okay, so that's why the reason you have this minus s of 3. Again, these are your distances, that's why it's times 2. And then minus S3 because of this, let's say, unfinished, okay, business, or okay, you didn't go through here. Okay, that's it. All right, and then what are the common phrases in some problems? Okay, so the first one is t seconds after passing through the origin. You might see this in some questions. So when you see this, that means time is 0 because it's in the origin, right? So that means that the displacement is also 0. Okay, or maybe you might encounter this returning to its origin at t is equal to a or s. Okay, or a can be any second. Okay, so s of a is equal to 0. So returning to its origin. Okay, so it went back here. Well, that's 0 because it went back to the origin. So it touches that place again. And then for this, maximum displacement and minimum displacement. So think about your maximum and minimum point before. So it's also worked that way. Okay. So basically, if you're asked for the maximum displacement, you get the derivative of s, or the derivative of the displacement, and then that is equal to 0. By the way, the derivative of the displacement is your velocity. So that means if you see this, velocity is equal to 0. And then if your answer here on your second derivative is a negative, that means it's maximum displacement, or before its maximum point. And then same with this. Okay, so velocity, or the derivative of displacement, or ds over dt. Okay, so this is the derivative of displacement with respect to time is equal to 0. So if your answer here for your second derivative is a positive, that means it's a minimum displacement. Okay, so I hope you still remember your maximum and minimum point topic before, because it also applies here. Okay, so that's displacement. Now, how about velocity? Okay, so basically, velocity and speed are related, but what's the main difference between the two? Okay, so first, let's define velocity. The velocity of an object is the rate at which an object changes its position. Well, speed, what is speed? So it's distance over time, right? Okay, but velocity is also speed, but this time it has, what do you call it? It has direction. Okay, so going back to our EMATS topic, okay, if you still remember vector and scalars, now speed is scalar because it doesn't have any direction. It can be going anywhere. Okay, that's speed. But we're in velocity. This is vector because it has speed and direction. Okay, it has speed and direction. So that's basically velocity. And how do we get velocity? By deriving the displacement function. Okay, and then what are the common phrases that we will encounter, class? So if it says initial velocity in your question, velocity is at t is equal to 0 seconds. Okay, so initial means it's the start. Okay, or initial velocity. Okay, Okay, so initial velocity. And the next is instantaneously at rest. This one, you will commonly find this in the questions in the book. So what does it mean when it says instantaneously at rest? So basically, the velocity is also equal to 0. Okay, 0 meter per second. And then maximum and minimum velocity is basically the same way as minimum and maximum point. Okay, so in here, you get the derivative of velocity, and they basically that's the acceleration is equal to 0. So getting the second derivative of each, if it's negative, it's maximum velocity. If it's positive, it's minimum velocity. Okay, but most of the time you will see this two phrases in the questions. Okay, and also, class, this is an important note that you need to remember. Okay, whenever you see the instantaneously at rest, this usually correlates to the particle or an object turning, okay, or returning. Okay, so let's say from the origin goes here, and then it goes back like that. Okay, so this point here, you will find that instantaneously, okay, uh, at rest. So when you see this, that means that the particle is turning back. Okay, it's going back. All right. All right. And then one more thing. Okay. Uh, you might wonder, why do I get a positive and a negative velocity? Okay. So basically, class, when it's positive velocity, just like in your x and y plane, uh, it goes to the right, or yeah, it goes this way. Okay, or going away from the origin. And then if it turned back, that means that your velocity here is negative. Okay, so if you see, let's say, positive or 5 meter per second, that means it's going to the right. Okay, and then if you see, let's say, negative 3 meter per second, so that means it's going back to the origin. Okay, so that's the basic difference between a positive and a negative velocity. And then lastly, okay, so this might be the shortest one. So acceleration is, the rate of change of the object's velocity. Rate of change. You have studied this in Sec 3, right? Okay, so basically, to get the acceleration of an object or a particle, so you just need to get the second derivative of the displacement, or get the derivative of the velocity function. Okay, just that. Only that for acceleration. Okay. And everything here is in terms of time. Okay, always the t, because everything here is measured in time. Okay. Okay, so I think that's it. We can have some examples now. Okay, so as we go through the different examples, you can raise some questions. Okay, because most of these are all word problems. Okay. All right. So let's have number one. Okay. Class, do you have any question before we proceed with number one? None. Okay. So let's have number one. Okay. So a particle Q moves in a straight line. Okay. So that its distance s m, or in meters, from a fixed point O, or the origin, is given by this. So s is equal to 6t squared minus t cubed. Okay, so that's the function of displacement, where t is the time, of course, in seconds after passing O. That means origin. So find A, the velocity and speed of Q after 5 seconds. B, the distance of Q from O when it's instantaneously at rest. So you see this one again, after passing through O. And then letter C is the total distance traveled during the first 5 seconds. Okay, so let's head first with letter A. Now, so let's say this is your origin, right? So a particle or something moves toward its right, okay? And then the displacement of this, let's say it's here, is s is equal to 6t squared minus t cubed. Okay, I don't know what happened. Okay, anyway, this is the function. Okay, so for letter A, we need to find the velocity and speed of Q after 5 seconds. So we're given this function here for displacement. So in order for us to get the velocity, we need to get the derivative of s. Okay, so doing that, so we have it here. So velocity is equal to the derivative of s, which is 12t minus 3t squared. Do you have any question, class? So basically, this one came from here. So I just derived this to get this one. Okay, so that's it. So we have now our velocity function. Okay, so every now and then, if it's asking for velocity, we're going to use this, right? So the question says after 5 seconds. So therefore, time is 5 seconds. Okay, sometimes the book adds a letter s here. Okay, so let me just, okay, but it's the same. T is equal to 5. And then, so therefore, the velocity of the particle or object is a negative 15 meter per second. Okay, so the velocity is negative 15 meter per second, and its speed is 15 meter per second. By the way, speed is the absolute value of velocity. Okay, it's like if you remember magnitude. Okay, so speed is always positive. Okay, so that's your answer. So that's the velocity and speed of the particle. Now, letter B. Let's continue with letter B. So for letter B, the distance of Q from O when it's instantaneously at rest. Okay, so let's say from the origin. Okay, so this is O, and then this is, let's say, Q. Okay, so that means it's uh, instantaneously at rest. So again, if it's instantaneously at rest, it will turn from this point right here. It will go back. Okay. So again, if you see this phrase, that means velocity is equal to 0. So given this, it came from letter A. Okay, so velocity is equal to 0, right? So therefore, we first need to solve for the time. Okay, because we cannot solve for displacement or distance without time. Okay. All right, so that's it. So given the velocity and it's instantaneously at rest, so v is equal to 0. Solving this, okay, so I factored them out. So t here is 0 or 4. Okay, of course, it cannot be equal to 0 because if it's 0, it's still on the origin. Wherein if it's 4, that means it's already moved away from the origin. So it's at a distance now. Okay, so if t is 4, okay, we go for 4. So that means to find for the distance, okay, is also finding for the displacement. Okay, now s is equal to 6t squared minus t cubed. You might be wondering, this is displacement, this is also a distance because it's a straight line, right? Straight line. So you remember the road question a while ago? Okay, so the road is also straight, just like the distance. So they're equal. Okay. So getting this, so 60 squared minus t cubed, basically you just plug in 4 and then you'll get 32 meters for your distance. Okay, so the distance of Q from the origin is 32 meters. So that's it. Okay. Do you have any question for letter B? Sec 4? None so far? Okay, so let's continue and finish letter C. Okay, so for letter C, it's asking for the total distance traveled during the first 5 seconds. Okay, all right. So during the first 5 seconds, that means that t is equal to 5. Okay, that's for 5 seconds. And then let's get the distance or the displacement of that. Okay, after 5 seconds, and that's 25 meters. Okay, 25 meters. Sorry, I forgot to write the unit here. Okay, so please observe, class. that after, okay, let's say here 4 seconds, the distance is 32 meters. But then after 5 seconds, it's lesser, 25 meters. Okay, that's because on letter B, the particle is instantaneously at rest. That means that it's turning or it's returning, okay, to the origin. So that's why after 5 seconds, it's now at 25 meters away from the origin. So this is 25 meters. Okay. All right. So it's illustrated it here. Okay. So this is the origin. Origin is time 0. Displacement is 0. And then here, velocity is 0 because it's instantaneously at rest from letter B. And then time is 4 seconds. And then the displacement is 32 meters. So yeah. So again, so this is 32 meters, right? And then for letter C again, so if time is 5, the displacement is 25 meters. So to get the total distance covered, okay, here to here, so it's 32 times 2. Okay, this is again 32. Okay, so going here, this is 32. Going back is another 32. That's why it's times 2. But then you need to subtract 25 because of this unfinished travel. Okay, so that's it. That's why minus 25 gives you 39 meters. Okay. All right. So that's number one. Sec 4, do you have any question? Hmm? Any question that you want to ask before we go to number 2? No question, Sec 4? Okay. All right. So let's go with number 2. Okay. Just a tip, class. So um, be familiar with those phrases that I told you from my previous slides because there will be a lot of those phrases in some questions, and it might be handy for you guys to you know to recall those things. Okay, so let's go to number 2. Okay, so for number 2, let me read. The particle or a particle P moves in a straight line so that its displacement s from a fixed point origin. Okay, so again, if you want to draw that, it will be like that. Okay, so this is your origin, and P or particle P is moving, okay, towards there. Okay, straight line. Okay, and then the function of the displacement is 3t squared minus 12, where t is the time in seconds after passing a point A on the line. Okay, so first, letter A, let's find the distance of OA or origin up to point A. Okay, so you still remember vectors? Okay, OA, origin to point A. So at A, time is equal to 0. Okay, because it's still on the uh, origin. Okay, or we start from the origin. So for that, so the displacement of this is equal to 3t squared minus 12 given by this. So if time is 0, therefore the displacement is negative 12. Okay, again, uh, it's asking for the distance, right? So the distance is the absolute value of the displacement. That's why this is 12 meters. So distance is always positive, guys. Okay, and displacement can also be negative or positive. Okay. Okay, class. Let me read that. Okay, so this is positive displacement, and then this is negative displacement. Okay. All right. So that's letter A. So that's the distance. It's 12 meters away from the origin. Now, for letter B, let's find the velocity of P when it passes the origin. Okay, passes the origin. So it's asking for the velocity. So, okay, before we derive for the velocity function here, so what I did here is to find for the time, okay, because the time is only the constant thing among these three. Okay, we cannot solve velocity without the time. Okay, so passing at O or origin, displacement is 0. Okay, so therefore, using your displacement function, S is equal to 0. Okay, so what do we do? So we solve for T. Okay, solving for T. Okay, basically getting the root of 4 is a positive and a negative 2, right? But take note of this, the time is always equal or greater than 0. There can't be no negative second, okay, or negative time, okay? So if you're given a choice of a positive and negative time, we'll always go for the positive or 0, okay? Can be 0, can be positive, but never negative, okay? All right, so if t is 2 seconds, then it's asking for the velocity of p. I'm given this function here, the displacement function. If I'm going to solve for the velocity, I need to derive this, right? So doing so, deriving this, I will end up with 6t. Okay, 6t. All right. No question here. Okay, so basically, if you don't remember, it's 2 times 3 is 6, and then 2 minus 1, that's why it's just t right here. And then negative 12 becomes 0. Okay, so that's why it's just 60 over here. So if time is 2 seconds, so just plug in 2 here. So 6 times 2 is 12 meter per second. So this is your velocity. So the velocity of P is 12 meter per second. Okay, so we have the distance from letter A, we have the velocity from letter B. Okay, now let's go with letter C. So letter C, let me read the question again. Show that P never comes to rest after passing A. Okay. Now, after passing A, time that, it says never comes to rest, right? So it kept on moving towards its right because it's a passive velocity, right? So time here is always greater than 0. Okay, so this is just a very short answer. So if the velocity is equal to 60 and it never comes to rest, that means it's greater than 0. So that means what is this expression? Uh, what's the meaning of this expression? So that means that all your answers for velocity are positive. It's a simple proving question. Okay, that means whatever you plug here greater than 0, let's say 1, 2, 3, 4, 5 seconds, your answer will always be greater than 0. So that means that peak continued going straight to the right. Okay, so that, yeah. So P never comes or never came to rest. So that's for letter C. And then for the last question here, letter D, let's find the average speed of P during the first 3 seconds. Okay, so what does it mean? Average speed. Do you still remember your average speed? Okay, so average speed is equal to the total distance covered over, yeah, the time covered as well. Okay, so let's go with letter D. Okay, so again, the question is during the first 3 seconds. So therefore, T is 3, and then we need to find for the displacement after 3 seconds. So it's 15 meters. Okay, 15 meters. Okay, so when you illustrate that, so A here is negative 12, right? Why is this here? Okay, okay, so let me erase this. Okay, Okay, so basically point A is here. When time is 0, point A is at negative 12 away from, okay, this one, okay? So it came from letter A. That's why the displacement is negative 12. That's, okay, it went here, okay? This is negative displacement. It's on the left of the origin. Think of your x, x and positive x and negative x's, okay? So if it's negative displacement, okay, that means it's before the origin. That's why it's negative 12 over here, okay? The distance, though, is still 12 meters, okay? Because distance is absolute, okay? So it's always positive, okay? But then displacement, it has negative and positive, okay? So time is 0. The displacement is at negative 12. So the particle started from here, passing through the origin that we answered from letter B, okay? So this is the velocity. So, okay. And then for letter D, okay, after 3 seconds, it came here, 15 meters away, okay, from its starting point, right? So to get the average speed, so this is the distance or total distance, okay? So here to here, you have 27 units, okay? All right, so that's 27 units. This is distance. Wait, let me write that. Okay, distance covered, and then this is seconds. Okay, because it's asking for 3 seconds. And then your answer here, the average speed of the particle is 9 meters per second. So from here, it's moving 9 meters per second towards here. Okay, and after 3 seconds, it's right here. So that's the average speed of the particle or object. Okay, Sec 4, do you have any questions? Okay, so probably I'll have one more, last one. Okay, and I'll just give you one homework for tomorrow. Okay. Okay, so let's have this one. Now for number 3, we now have some acceleration questions here. Okay, so let me read the question first. Now, a particle again travels in a straight line so that t seconds after it started moving, its displacement s meters from a fixed point origin on the line is given by this function right here. So 6 minus 9 over t minus in t plus 3. So let's find letter A, the expressions for the velocity and acceleration of the particle in terms of t. So class, you're given a displacement function and it's asking for the velocity and acceleration function. So what do we do? If you still remember the S, V, and then A, if going here and going here, we need to derive, right? Those things, okay? So given the displacement function, to get the velocity function, I'll just need to derive this. So deriving this is my answer right there, okay? Okay, so again, how did I derive this? So basically, 6 here and then t plus 3, I rewrote that, so I don't have to perform quotient rule. So I put that here, so that's why this is raised to negative 1 or to the negative 1 power, okay? So getting the derivative of this, so 6 becomes 0, and then negative 9 times negative 1 becomes positive 9, right? And then negative 1 minus 1 gives me negative 2. So therefore, uh, my velocity function is 9 over t plus 3 squared. Okay, so that's for my velocity. Now, how about for my acceleration function? So for my acceleration function, basically, I just need to derive this, okay, the velocity function right here. So deriving this, okay, again, I don't want to use quotient rule. What I did here is just to put it here in the numerator. That's why this is raised to negative 2. Okay, so deriving this, negative 2 times 9 is negative 18. Negative 2 minus 1 is negative 3. So therefore, my acceleration function is negative 18 over t plus 3 cube. Okay, so that's letter A. So those are the functions for displacement, velocity, and acceleration. Okay. Okay, now let's have letter B. Now, letter B is asking for the velocity of the particle when it is 5 meters from O. 5 meters from O. Okay. Basically, class, if it's asking for the velocity and we're given the distance, we need to solve first for the time. Okay, always look for the time first because we cannot measure any of these three without the time. So if we know that the particle is 5 meters away from the origin, so using the displacement function given, okay, s is equal to 5 now, and then what do we need to do here? We just basically need to solve for t, for the time. So solving this, okay, so transpose it, can become negative 1, and then cross multiply here, becomes negative t minus 3 equals negative 9. So therefore, t here is 6 seconds. Okay, 6 seconds. Okay, so with that, okay, so if the particle is 5 meters away from O, that means it took the particle 6 seconds to get to 5 meters. Okay, so for that, I can now solve for the velocity. So the velocity here is from this one, okay, from letter A. So basically just plug in 6 seconds, there are 6, and then you will get your answer as 1 over 9 meter per second. And yes, you can answer in decimal as well. Okay, so that is the velocity of the particle. Okay, that is 5 meters away from O, or the origin. And the last question, let's find for the time when the acceleration of the particle is negative 12 meter per second squared. Okay. Again, take note the unit for acceleration is second squared. Okay. So how do we do that? So if given the acceleration is negative 1 over 12, by the way, before we continue, if you see a positive acceleration, that means that it's accelerating. Okay. If it's negative, that means it's decelerating. Okay, or it's going slower and slower. Okay. Okay, so let's go back here. So we're given this acceleration function from letter A. So this is negative 112 now. Okay. So what do we need to do? Because we're looking for time, so we just solve for t. How do we do that? From here, I just cross multiplied them. Okay. So negative 1 times this. Okay. And 12 times negative 18. Basically, class, this is negative times negative. So therefore, they became both positive. Okay. If you want to make them both negative, it's fine. You will still get the same answer. Okay. So anyway, this one becomes this. So t plus 3 cubed. Then 12 times 18 is 216. Okay. So solving for t, so get the cube root of this. So cube root of 216 is 6. So therefore, t is 3 seconds. So that's your answer for letter C. So that's the